lithosphere provides habitat and nutrients. Okay. Next one is the living organisms. This is the nothing but biosphere. It includes plants, animals, and microorganisms is there. Ecosystem concepts is there. Ecosystem is called living organisms plus physical environmental. It includes biotic components and abiotic components. Biotic components are like plants, animals, microorganisms. So abiotic components means air, water, soil, sunlight, and temperature. All these components interact with each other to maintain ecological balances. Okay. Uh, I will share some PPTs. Some definition of uh, what is the pollution. Okay. Uh, the topic discussion water pollution already is done. Okay. Definition of some pollutions. Okay. Definition of pollutions. Okay. Pollution is the unfavorable alteration of the surroundings due to physical, chemical, or biological changes in the environment. Okay. First one is the nature of changes. Means pollution may involve physical challenges like heat, noise, radiation, and solid waste. And chemically changes are toxic gases and pesticides and heavy metals. So biological changes like pathogens, harmful microorganisms. There effects of pollutions. What is the effects of pollution? Uh, Harmful to living organisms, disturb ecological balance and damages ecosystems, affect human health and diversity. Okay. Mainly pollution occurs when harmful substances or changes degrade the natural quality of air, water, or land, making the environment unsafe life. Okay. Coming to the next slide. Historical awarenesses of waterborne diseases like cholera, typhoid, and hepatitis. Chemical disasters are minimeta and itai. Okay. Look at this. Waterborne diseases. What is the waterborne diseases? Historically, polluted water has caused major diseases outbreak like cholera, several diarrheal diseases caused by contaminated drinking water. Okay. Typhoid spread through water contaminated with Salmonella typhi. Typhoid occurs with Salmonella typhi. Hepatitis A and E. Viral infection is transmitted through unsafe water. Okay, these diseases highlighted the importance of safe drinking water and sanitation systems. Okay, major chemical disasters are minimeta diseases. Okay, in this many meta diseases like occurred in Minamata Bay in Japan in 1950s, okay, caused by industrial discharge of methyl mercury, caused by industrial discharges of methyl mercury from a chemical factory. Okay, led to several neurological disasters and deaths occur. A landmark case in environmental awareness is there. Itai diseases. Second one is the Itai diseases reported in Japan early 20th century, caused by cadmium contamination from mining activities. Okay, caused by cadmium contamination from mining activities, resulted in bone deformities and extreme pain is there. Okay, itai means ouch in Japan. Okay, what is the significance? These historical events created global awareness about the dangers of industrial pollution, the need for environmental laws, safe waste disposal practices, and public health protection. Okay, mainly in this water pollution had serious historical consequences from deadly waterborne diseases to large-scale chemical disasters. These events emphasized the urgent need for environmental protection and sustainable water management. Okay. Next one, the coming to the global water distribution. In this, 71% of it covered by water. Okay. In this overview, uh, mainly 71% of the Earth's surface is covered by water, but nearly 97 of total water is found in ocean and seas only. Okay, only 3% is the fresh water, and most of it's not directly accessible for human use. Understanding global distribution is fundamental for hydrology, environmental science, and water resource management and climate studies. Okay. Uh, uh, a quantitative distribution of earth water. What is the quantitative distribution of earth water? Total water on earth equal to 1.386 billion kilometer cube. Okay, mainly saline water. It means ocean water is equal to 97%. Ocean and seas. Okay, oceans and seas. Only 97% available in oceans and seas. High salt concentration. It means equal to 35 ppt average salinity. Okay, it is more salty. It is not usable for drinking. Okay, not suitable for drinking for or irrigation without desalination. Okay, major role in climate regulations, carbon sequestration, and global heat reforestation. Okay, uh, coming to the freshwater, it is equal to only 3%. The freshwater 3%, the 3% freshwater is unevenly distributed. Some in this 3% is glaciers and ice caps 68 to 69% locked in Antarctica and Greenland. Okay, approximately 68 to 69% locked in Antarctica and Greenland. Moreover, 30% of groundwater, major sources of drinking water. Okay, the groundwater is nearby 30% and major sources of drinking water. Surface water is only 1% only in uh, lakes and rivers, wetlands. Only 1% is there. Okay, less than or 0.01% part atmospheric water is part of hydrological cycle is there. Okay, freshwater availability and human use. Major uses of agriculture nearby 70% globally, and industry 20% use, and domestic use only 10%. Mainly issues are over extraction of groundwater. Okay, glaciers melting due to climate changes, surface water contamination, uneven geographic distribution is there. Countries with large freshwater reserves include Brazil, Canada, and Russia. Hydrological cycles connection is the global water distribution is dynamic due to the hydrological cycle. First one is the evaporation and condensation and precipitation, infiltration and runoff. Okay, climate changes alerts are precipitation patterns and glaciers mass balance and sea level rise. Okay, coming to the ecological and environmental significance. In this, ocean regulate the global temperature, and freshwater ecosystems support biodiversity. Wetlands act as natural filters. Groundwater maintenance waste flow in rivers. Okay, distribution in the di- dispersion in the distribution leads to water scarcity, desertification, and food insecurity and conflict over resources. Okay, main critical analysis. For some key points is there, blue water versus green water, mutual water trade. Okay, although Earth appears with rich usable freshwater is extremely limited, less than 1% of total global water is rarely available for human consumption and ecosystem needs. Sustainable management is essential to ensure long-term water security. Okay, coming to the next slide. uh, Usable freshwater. Most of the freshwater in ice and groundwater, and only 0.03% usable. Okay, uh, in this, although freshwater constitutes about 3% of total global water, only a very small fraction. It means 0.003% of total water. Okay, is readily usable and accessible for human consumption and ecosystem services. This highlights the concept of hydrological scarcity despite apparent abundance distribution of fresh water. Ice caps and glaciers 68 to 69 of fresh water located mainly in polar regions and high mountains. Okay, major storage in Antarctica and Greenland, locked in frozen form. Okay, not directly accessible without significant technological and economic investment. Climate change is accelerating glacial melt to sea level rise. Okay, groundwater is the nearby 30% of fresh water stored in aquifers and beneath earth surface, primary sources of drinking water in many countries. Over extraction leads to land subsidence and aquifer depletion and saline instruction to coastal regions. Okay, when surface water is equal to 1% only, 1% of fresh water, it includes rivers and lakes and wetlands. Only a small portion of this easily accessible and potable. Uh, why only 0.03% is usable? The figure 0.03 usable refers to freshwater in rivers and lakes only. Easily accessible groundwater. Water suitable for immediate human use. Okay. Some limitation is there, mainly geophysical event distribution, seasonal variability, pollution contamination, economic and infrastructure contaminates. Uh, Construction needs. Okay, some ecological significance of usable freshwater is even this tiny fraction sustains terrestrial and aquatic ecosystems is there, and some supports agriculture, means largest consumer globally, and maintenance biodiversity, regulates micro climate. Okay, loss or contamination directly affects our food security, public health, and economic stability. Some contemporary issues are water stress and scarcity, climate change impacts, and anthropogenic pressures. Okay, policy and management implications is there, sustainable strategies and advanced concept is there. Okay, coming to the next slide, hydrological cycle. In this hydrological cycle, nothing but called as a water cycle. The hydrological cycle is the continuous circulation of fresh water, continuous circulation of water between the atmosphere, hydrosphere, lithosphere, and biosphere. Okay, it is a solar driven and gravity control system that maintains the global water balance. Uh, it regulates the climate and freshwater availability and ecosystem functioning and biochemical cycles. Okay. Second one is that major process of the hydrological cycle. In this, first one is the evaporation. Okay. Evaporation means conversion of liquid water into water vapor due to solar energy. Major sources are oceans. Almost nearby 86% of global evaporation includes transpiration from plants, together called evaporations. Evapo evapotranspirations. Okay, influenced by temperature, wind speed, humidity, and surface area. Okay. Second one is the condensation. Condensation means cooling of water vapor into liquid droplets, leads to cloud formation and occurs when air reaches a dew point temperature, releases latent heat, influences atmospheric circulation is there. Precipitation is there. Some water falls into earth as rain, snow, silt, and hail. Some types is there: conventional precipitation, orographic precipitation, and cyclonic precipitation. Okay. Uh, and runoff. Fourth one is the runoff, movement of water over land into rivers, lakes, and oceans. Occurs when precipitation exceed infiltration capacity, contributes to river discharge, flood formation, and soil erosion. Factors affecting runoff: land slope, vegetation covers, and soil depth, and urbanization is there. This one is the infiltration, downward movement of water into soil, recharge groundwater aquifers controlled by soil porosity and soil permeability and moisture content, and land user. Okay, land use. Uh, Mainly storage components of oceans, iceries and ice caps, and groundwater, surface water, and some community. Next slide. Sources of fresh water. What is the sources of fresh water? Mainly, freshwater resources are vital uh, for sustaining life, agriculture, industry, and ecosystem. The two primary sources of fresh water are surface water and groundwater. One is the surface water, and second one is the groundwater. Okay. Uh, in this, both are interconnected components of the hydrologic cycle and play a crucial role in global water security. Uh, uh, First one is the surface water. Surface water refers to the water present on the earth surface. In first one, in this rivers, flowing bodies of fresh water, major sources of for drinking, irrigation, and hydropower, recharge groundwater through infiltration, and highly vulnerable to pollution and seasonal variability. Okay. Second one is the lakes. What is in this in land water bodies and can be natural or artificial, store large volume of fresh water and important for biodiversity and climate regulation. Okay. uh, Another one is the reservoirs, artificial lakes created by damming rivers. Okay. Used for irrigation and drinking water supply, flood control, hydroelectric power generation. Surface water is easily accessible, highly dynamic, and more susceptible to contamination. Okay. Next, go to the about talking about groundwater. Groundwater is water stored beneath the earth surface in soil pores and rock formation. In this, we're talking about aquifers. Aquifers means permeable rock formation that store and transmit water. In these types are unconfined aquifers and confined aquifers. As second one is the storage mechanism. In the stored in soil pores, sand and gravel layers, and fractured rock systems is there. In this, groundwater is more protected from direct contamination, less prone to evaporation losses, and generally more stable year around. Okay. Last one is the comparative analysis. In this, accessibility parameter equal to high surface water and groundwater is the more moderate. Pollution risk in surface water is high and groundwater in moderate or slow contamination. In the seasonal variation, surface water is high and groundwater is very low. Storage capacity is surface water is limited, but groundwater is the large, and recharge rates are in surface water is the fast and groundwater is the slow. Okay. Interconnection between surface and groundwater is the reverse recharge aquifers. Groundwater maintains river base flow during dry periods. Excess groundwater extraction reduces river flow. Integrated watershed management is essential for groundwater storage, and mainly in this environmental and management issues are there. That one is the surface water issue, groundwater issues. Okay. In this, mainly surface water and groundwater are the principal sources of fresh water. Okay. Although groundwater constitutes a large share of usable fresh water. Both sources are interdependent and must be managed sustainability to prevent depletion and contamination. Okay, coming to the next slide. Aquifers. Aquifers means an aquifer is a water-bearing geological formation capable of storing and transmitting significant quantities of groundwater. Aquifers form an essential component of the sorry, sorry, component of hydrological system and supply nearly 30% of water global freshwater used for domestic, agriculture, and industrial purpose. Okay, aquifers from an essential component of the hydrological system and supply nearly 30% of global freshwater used for domestic, agriculture, and industrial purpose. Okay, in this, an aquifers is a permeable rock or sedimentary layer like such as sand, gravel, limestone, or fractured rock. Okay, stores groundwater in ports and fractures allows movement of water through permeability and can yield usable water to wells and springs. Okay? Types of aquifers are unconfined aquifer. It means water table aquifer. Upper boundary is the water table directly recharged by rainfall and surface infiltration. No impermeable layer above. Water level fluctuates seasonally. Okay. Main characteristics are easily recharged, more vulnerable to contamination, and common in shallow depth. Okay. Confined aquifer means sandwiched between impermeable layers, sandwich between impermeable layers, and water is under pressure. Okay, when tapped, water may rise above the aquifer level. Okay, main characteristics are recharge occurs at distant outcrops areas, less vulnerable to surface contamination. Water is often old. Okay, in this related to geological terms is there. It means term is aquatite, meaning semi-permeable layer restricted water flow. It means aquatide. Okay. Aquiclude means impermeable layer storing but not transmitting water. Okay. Aquifers means neither stores nor transmitted water. Okay. Water table means upper surface of unconfined aquifer is there. Okay. Aquifer properties are porosity. First one is the porosity. Porosity means percentage of void space in rock determines storage capacity. Permeability means ability to transmit water and determines yield. Okay. Hydraulic conductivity means a rate at which water moves through aquifer material. Okay. Transmittivity means capacity of aquifer to transmit water across its thickness. Okay. Uh, Last one, the ecological environmental importance. Okay. In this supplies drinking water, supports irrigation, maintains river-based flow. Okay, prevents land subsidence. Okay, threats to aquifers are over explanation. Over exploitations means declining water table, reduces well yield, and land substances. Okay, some contamination is there. Industrial effluents, agriculture chemicals, and arsenic and fluoride mobilization, and seawater instruction in coastal aquifers. Okay, in this some climate changes are there. Altered recharge patterns, increased drought frequency. Okay, suitable management strategies are managed aquifer recharge and rainwater harvesting, conjunctive use of surface and groundwater, regulation of extraction and groundwater modeling and monitoring. Okay, and this mainly conclusion is the aquifers are crucial subsurface reservoirs that sustain human civilization and ecosystems. Understanding their structure, function, and vulnerability is essential for suitable groundwater management at local, region, and global scale. Coming to the next slides, urban water supply. Main sources are lakes, rivers, and reservoirs. Treatment are clarifications and filtration and chlorination. Okay. In this, mainly urban water supply means urban water supply systems ensure the provision of safe, potable water to city population for domestic, industrial, and commercial use. Okay. Rapid urbanization and population growth and climate variability have increased pressure on urban water infrastructure. When sources of urban water supplies are first one is the surface water, primary sources including rivers, lakes, and reservoirs. Reservoirs are dams. Advantages are large storage capacity is there, easier abstraction is there, suitable for centralized treatment, and challenges are pollution risk, seasonal variability, and upstream contamination is there. Coming to the groundwater, it means supplementary sources, bore wells and tube wells used during shortages and often requires less treatment but may contain fluoride, arsenic, and iron. Uh, Another one is the water treatment process. In this, urban water undergoes multiple treatment stages to meet drinking water standards. Is there? First one is the clarifications. Okay, coagulation or sedimentation. Purpose remove suspended solids and turbidity. In these steps involve addition of coagulants. Example alum. Okay, a formation of flux and sedimentation in settling tanks. Okay, removers are mud and organic particles and some microorganisms. Okay, the second step is the filtration. Filtration means purpose are remove fine particles and pathogens. Types are rapid sand filtration, slow sand filtration, and pressure filtration filters. Okay, removers are suspended particles, protozoa, some bacteria is removed. Okay, another stage is the final stage is chlorination. It means also disinfection stage. Purpose kill pathogenic microorganisms. Okay, in this chlorine gases are bleaching powder added. Okay, chlorine gas or bleaching powder added. Maintenance residual chlorine in distribution systems. Effective against bacteria and viruses. Limitations may form disinfection by products like THMS. Okay, distribution system. What is the distribution system? After treatment, stored in overhead tanks, distributed via pipelines. Okay, pressure maintained through pumping stations. Challenges are leakage losses and cross contamination and aging infrastructure. Another one is the water quality standards. In this urban water, most commonly with WHO drinking water guidelines or national standards is there. Example BAS in India. Okay, national standards. Uh, uh, Parameters monitored by pH, turbidity, total dissolved solids, also TDS, coliform bacteria, and residual chlorine. Emerging urban water issue. Emerging issue are water scarcity and some uh, urban flooding and intermittent supply and climate changes. Okay. Uh, in this mainly urban water supply system depend primarily on surface water sources such as lakes, rivers, and reservoirs, followed by systematic treatment through clarifications and filtration and chlorinations. Okay, ensuring a safe and sustainable urban water supply requires advanced management strategies, infrastructure, modernization, and strict water quality monitoring. Okay. Coming to the next slide, rural water supply. In this rural water supply systems are designed to provide safe and adequate drinking water to disparate population in village and remote areas. Unlike urban systems, rural water supply often releases on local and decentralized sources with a limited treatment infrastructure. In the sources of rural water supply, what is the sources of rural water supply? First one is the wells and rivers and lakes. It means wells. Wells means open wells, tube wells, like bore wells. Main characteristics are direct access to groundwater, less seasonal variation is there, and risk of contamination from nearby sanitation system. Second one is the rivers. It means used directly in many rural settlements, highly seasonal and vulnerable to upstream pollution. Okay. Third one is the lakes, lake and ponds, common in villages. Okay, used for domestic and agriculture purpose, susceptible to eutrophication and pathogenic contamination, and livestock in interference is there. Okay, some water quality assessment in rural areas are traditionally rural communities judge water quality based on taste, color, odor, and appearance. Okay. However, this method is unreliable because many pathogens are invisible and chemical contamination like arsenic and fluoride are tasteless, and clear water may still be microbiologically unsafe. Okay. Fourth one is the major rural water quality issues are microbial contamination like fecal coliforms, E. coli, waterborne diseases like cholera and typhoid. Second one is the chemical contamination like arsenic, groundwater in create in certain regions. Okay, fluoride causing fluorosis, iron and nitrate contamination, and another one is the seasonal scarcity, declining water table and drought conditions. Okay, treatment methods in rural areas are basic methods are boiling, filtration means a cloth or sand filters, chlorination tables is there. Improved systems are hand pump based supply, community water purification units. Sorry, sorry, community water purification units and solar disinfection and rainwater harvesting is there. Main challenges in rural water supply: lack of infrastructure, poor maintenance, limited water quality monitoring is there, financial constraints and gender burden. Okay, human traveling long distance, like this is the called gender burden. Okay, main sustainable rural water management is the community participation, watershed development, and groundwater research structure, decentralized water treatment systems, and regular water quality testing. Okay, main in this critical conclusion is means rural water supply depends mainly on wells, rivers, lakes with water quality traditionally judged by sensory characteristics such as taste and appearance. However, modern public health perspective emphasize the need for scientific testing and suitable management to ensure safe drinking water in rural areas. Okay. Next one is the concept of water quality. Okay. Concept of water quality means water quality refers to suitable for water for a specific use based on its physical, chemical, and biological characteristics, and water that is safe for one purpose may not be suitable for another. Therefore, water quality is used dependent and context specific. Okay. In this, water quality is defined as the physical, chemical, and biological characteristics of water that determine its fitness for intended use, such as drinking, agriculture, industrial processes, and um, recreation, aquatic ecosystem support. Okay, major water quality parameters are physical parameters are these describe the observable characteristics of water. One is the temperature, influence chemical reaction and dissolved oxygen. Turbidity means cloudiness caused by suspended particles, color and odor. Indicate sorry indicate contamination, and total suspended solid, it means TSS, particulate matter in water. Okay, another one is the TDS, it means total dissolved solids, dissolved salts in minerals. dissolved salts and minerals. Okay. Mm. Chemical parameters are mainly these determine chemical composition and potential toxicity, like pH, acidity or alkalinity. Ideal drinking water pH is 6.5 to 8.5. Okay. Dissolved oxygen means essential for aquatic life. Biochemical oxygen demand. It means BOD, indicator of organic pollution. Okay. Chemical oxygen demand measure total oxidable pollutants. It means COD. uh, Nutrients like nitrates and phosphates, okay, causes eutrophication. Heavy metals like lead, mercury and arsenic. Hardness are means calcium and magnesium concentration. Okay. Biological parameters. What is the biological parameters? Indicate microbial contamination like total coliform bacteria, fecal coliform or E. coli, pathogens like viruses and protozoa, and algal blooms. These are critical for public health assessment. Okay. Water quality standards. What is the water quality standards? Water quality is regulated by WHO drinking water guidelines. Okay. National standards are included. Regulated by the BIS in India. BIS means Bureau of Indian Standards. Okay. Environmental research standards is there. Okay. Water is classified according to its intended use, like drinking water, irrigation water, industrial water, and recreational water. Okay. Water quality index. It means WQI short form. A composite indicator that integrates multiple parameters into a single value to represent overall water quality. Okay. Advantages are easily interpretation, useful for policy decisions and comparative assessment. Okay. Factors affecting water quality are natural factors are geological formation, climate, and social soil composition is the hydrological region. Okay. Anthropogenic factors are industrial discharge, agriculture runoff, and sewage disposable, and urban stormwater runoff is there. Ecological significance are water quality directly influences aquatic biodiversity, food chains, and public health ecosystem stability. Degraded water quality leads to eutrophication, fish mortality, and waterborne diseases and economic losses is there. Okay. In the whole concept, the of water quality is dynamic and purpose specific. It is assessed through physical, chemical, and biological parameters to determine uh, suitability of human for human use and ecosystem sustainability. Okay. Coming to the next slide. Water quality is use specific, not absolute, or depends on intended use. Okay. In this mainly, water quality is not absolute, it is relative and purpose dependent. Okay. Water consideration safe for irrigation may be unsuitable for drinking. Similarly, industrial cooling water and standards differ from ecological or recreational standards. Thus, water quality depends on the intended use. Okay. Conceptual understanding. Water quality is defined by the suitable of water for specific use based on physical, chemical, and biological characteristics. Therefore, no single water body can be labeled simply as good or bad. Okay, it must be evaluated against use based criteria or standards. Example of use specific standards. Drinking water requires zero pathogenic organisms, low turbidity, acceptable pH like 6.5 to 8.5, and low heavy metals, lead and arsenic. Okay, safe nitrates levels are focus on public health protection. Okay, main irrigation water. Second one is the irrigation deep. In this permits and moderate dissolved salts, certain nutrients levels and slightly turbidity. Okay. Third one is the industrial water. It means quality depends on process. Cooling water is equal to low scaling potential, and boiler feed water is a very low dissolved solids, and textile industry controlled hardness. Fourth one is the aquatic ecosystems requires high dissolved oxygen and low biochemical oxygen demand and balanced nutrient levels and absence of toxic chemicals, biodiversity and ecological stability. Okay. Main classification systems are water birds are often classified according to their registration best use, such as class A means drinking water after treatment. Okay. Class B means outdoor bathing. Class C drinking water after conventional treatment, and class D means wildlife or fisheries. Class E means irrigation, industrial and cooling. Okay. uh, Coming to the next slide. Importance of water quality. Okay. Introduction to importance of water quality. In this, water quality plays a critical role in sustaining human civilization, ecological balance, and agriculture productivity and industrial development. Since water is universal solvent and a key medium for biological and chemical process, its quality directly determines its suitable and safety in this human health. Importance for human health in safe drinking water. It means prevent waterborne diseases, cholera, typhoid, and hepatitis. Okay, reduces child mortality. Okay, ensure public health security. Okay, toxic chemical prevention. Second one is the toxic chemical prevention. Controls exposure to arsenic, fluoride, and lead and mercury. Sanitation and hygiene. Clean water is essential for sanitation systems. Poor water quality increases disease transmission risk. Okay. Third one is the importance of ecosystems like aquatic life support. Dissolved oxygen sustain fish and aquatic organisms. Balanced nutrients levels prevent eutrophication is a biodiversity protection. Clean water maintains species diversity and prevent habitat degradation. Is the ecological stability are water quality influence food chains, maintenance, nutrient cycling, and ecosystem services. Degraded water quality can cause fish kills and algal blooms, loss of biodiversity. Importance of agricultural crop productivity. Irrigation water quality affects soil fertility, high salinity residues crop yield, and soil health means excess sodium damages soil structure, and poor quality water leads to soil salination and alkalinity. Food safety means contaminated irrigation water may introduce pathogen into crops. Agriculture, being the largest water consumer globally, requires careful water quality management is there. Okay. In industry, process efficiency is the product quality. It means food, pharmaceutical, and textile industries and high quality water. Okay. Equipment longevity means poor water quality causes corrosion and scaling. Yeah. Coming to the next slide. Measurement systems. Water quality assessment requires systematic measurement efforts to determine suitability for specific uses. The three major measurement systems are used like direct management, quality indicates, and effect-based methods. So direct measurement means measurement of individual physical, chemical, or biological parameters using laboratory and field instruments. Okay. Example for parameters are physical means temperature, turbidity, DDS, chemically pH, DO, BOD, COD, nitrates, and heavy metals. Biologically, coliform count and plankton diversity is there. Okay. Tools and techniques are spectrophotometry, titration methods, and membrane filtration is there, and atomic absorption spectroscopy, DO meters and pH meters. Advantages are high precisions, parameter specific analysis, regulatory compliance monitoring, limitations are time consuming, requires skilled personnel, data interruption may be complex. Okay. Quality indicators are second one is the quality indicates. In this quality indicates a composite numeric value that integrates multiple water quality parameters into a single index score. Most commonly used in water quality index. What is the purpose? Main purpose of simplify complex data, enable comparison between sites and aid policy makers. Methodology are selection of parameters, assessment of weights and normalization, aggregation into a single value. Advantages are easy communication, public awareness, and useful for management decision. Main limitations are a loss of detailed parameter information, subjective weighting, and may oversimplify complex systems is there. Main effect-based methods are definitions are assessment based on biological response of organism to water contaminants. Types are bioassessors and biomonitoring, exotoxicology testing. Okay, and these are water quality measurement systems include direct parameter analysis, composite quality indicates, and biological effect based methods. Uh, Coming to the next slide, water quality criteria. In this, water quality criteria are scientifically established guidelines, specific acceptable limits of physical, chemical, and biological parameters in water for specific uses. They serve as the foundation for public health protection and environmental conservation, regulatory enforcement, and water resource management is there. Uh, Water scientifically derived concentration limits of substances in water that protect human health, ecosystem, and designated uses such as drinking, irrigation, and industrial applications. Is there? Okay. Types of water quality criteria are drinking water criteria means protect public health. Okay, and irrigation water protects soil and crop health, and industrial water criteria ensure process efficiency and equipment protection. uh, Basis of setting criteria are toxicological studies, ecological risk assessment, epidemiological data, and technological feasibility is there. Okay, coming to the next slide, water quality standards are regulatory limits. Water quality standards are legally enforceable regulatory limits established to protect public health, ecosystem, and designation to water users. Unlike water quality criteria, standards are mandatory and binding under environmental law. Definitions are mainly legally prescribed limits for physical, chemical, and biological parameters in water established due to ensure protection of human health, environmental sustainability, and intended users. Okay, main key features are legally enforceable, use specific, based on scientific criteria, and periodically revised. Okay, applied to drinking water and effluent discharge. Types of water quality standards. What is the types of water quality standard? Design standards are specific how facilities must be constructed and designed. Okay. Performance standards means specify the quality of water that must be achieved after treatment, and procedural standards are specify required procedure for complaints. Okay, drinking water versus effluent standards. Mainly, drinking water standards are protect public health, very strict microbial limits, and low tolerance for toxic chemicals. Effluent discharge standards are control pollution at sources, limited BOD, COD, heavy metals, prevent ecosystem damages. Okay. Sources of water pollution. Main point sources and non-point sources is there. Water pollution originates from various anthropogenic and natural activities based on the origin and discharge pattern. Sources of water pollution are classified into point sources and non-point sources. The classification is essential for regulatory control, monitoring, and pollution management strategies. Point sources of water pollution means point sources are identifiable and localized sources of pollution that discharge contamination into water bodies through a specific outlet. Okay, and non-point sources of water pollution are sources are diffuse and scattered sources of pollution without a single identifiable discharge point. Characters are widespread origin are difficult to monitor and control. Pollution occurs during rainfall or rainfall events. Point sources. Point sources are sources of water pollution are clearly identifiable and localized discharge point through which pollutants enter water bodies. Okay, and oil wells. Oil wells means oil extraction activities, particularly offshore drilling, and release pollutants through accidental oil spills and operational discharges, leakage during drilling. Okay, sewage pipes are municipal sewage system discharge domestic water through sewer outlets like pollutants are organic matter, pathogenic microorganisms, nutrients, and suspended soils is there. Okay. 9 point sources are agriculture runoff, urban stormwater, construction runoff. Non-point sources of water pollution are diffuse and some scattered sources that do not originate from single identifiable discharge point. Unlike point sources, they are difficult to monitor, highly dependent on rainfall and use. Okay, major non-point resources are agriculture runoff occurs when rainfall or irrigation water flows over agricultural land carrying pollutants into nearby water bodies. Okay, pollutants are fertilizers, pesticides and herbicides, animal manures and sediments. Okay, in these groundwater pollution sources, main groundwater pollution sources are fertilizers and pesticides. Okay, uh, mainly groundwater pollution refers to the contamination subsurface water stored in aquifers due to information of pollutants from subsurface activities like because groundwater moves slowly and has limited natural purification capacity. Contamination is often long lasting, difficult to detect early, expensive to remediate. Okay, major sources of pollution sources of fertilizers and pesticides mechanism. Excess fertilizers applied to agriculture fields uh, and dissolved in rainwater. Pesticides percolate downward via infiltration. Common pollutants are nitrates, phosphates, organophosphates, and organic pollutants is there. Impact. What is the impact? Impact are nitrate contamination causing methanohemoglobia and chronic toxicity is there, and bioaccumulation is there. Long-term aquifer degradation is there. Industrial waste sources are mainly effluent discharge. Without treatment, the industries are discharged that contaminated water into direct into lakes or some rivers, and leakage from storage tanks, improper hazardous waste disposable. It means not treated water and accidental spills. Okay, pollutants are heavy metals like lead, cadmium, and chromium. Organic solvents and petroleum hydrocarbons is there. Toxic chemicals is there. Okay, landfills is mechanisms are rainwater produces leachate content containing dissolved contaminations and leachate to nitrate soil and reaches qualification. Pollutants are ammonia, heavy metals, organic acids, some pathogens, and microplastics. Okay, water today session is closed. This time is up. Thank you. Thank being with me.